Hey, welcome to section 3, 3D shapes. Here's a quick rundown of what we will be doing in this section. So, besides the first video where I give you a basic app description, API, etc., in this section we will be creating 3D shapes, creating an app essentially where we work with plane detection, and from there we'll also do some really cool stuff with gesture recognizers and touch a little on lighting. So, moreover, what are we building? This app is basically somewhere between simple and not so complex. It's definitely a little bit more compared to the app in the previous section. We'll still be working with gesture recognizers. However, this time we take our knowledge a step up and we get involved in plane detection. As well, we work with a number of default 3D shapes common in ARKit. What APIs will we be using? Good question. Well, if you haven't already figured out by now, we will be using a lot of ARKit APIs. Specifically in this section, we will be utilizing instances of AR World Tracking Config, AR SCN View, SCN Node, AR Plane Anchor, SCN Plane, SCN Geometry, and, like I've listed, various AR SCN View delegates. Moreover, we will be utilizing UIKit, as mentioned prior, utilizing more UI gesture recognizers. Let's get started with building our app. Let's head over to Xcode and let's make a new project. Head to File, New, Project, Augmented Reality app. Let's call this 3D Shapes app. Hit Next, Create. We now have a brand new augmented reality app. Well, app template rather. So immediately out of the box, we have a few things that comes provided with this template. Basically a sample project. I believe it's a simple scene where you have a hovering rocket ship. So it's really cool. We actually won't need this. So let's head over to our hierarchy and let us head over to the view controller. As you can see, the template already has a lot set up for us. A good deal of it we will be using, however some parts we will have to omit because again we won't be specifically using this template that Apple has provided. So let's go ahead, let's create a new method, call this setup scene, and what this will do is essentially set up our scene with the requirements of an AR project. So let's go over and move this logic over. So I'm going to copy this logic into setup scene. Now, don't need a new scene. Well, actually we do need a new scene. So let's create a new scene. Let scene equals scn scene. Make a new scene instance. We will not be needing that. Now we have our setup scene method. We are going to call this from view did load. Okay, let's see what else we can eliminate. As you can see, the template already has our correct configuration, as well the session is, well, the method call to run the session is already set up, as well as the respective method to pause our scene view. Well, we won't be needing this stuff. As you can see, there's also a few methods that are already provided for us. We will be handling these a little later, but for now, just put them off to the side and let's continue on. Note for our configuration, we are using AR World Tracking configuration, but bear in mind, not all devices support world tracking. Moreover, we're going to need one more change here. Configuration plane detection equals horizontal. Also bear in mind that at the time of this recording, ARKit only supports horizontal plane detection. Perhaps in the future, we will have vertical and possibly more ways of doing plane detection. But for now, again, as of this recording, ARKit currently supports only horizontal plane detection. So all of what we've seen here is what we've already seen so far. Basically, we have a config. that we essentially run in our session, and we have a basic project setup. We're going to head over to the main.storyboard, and we're going to make some changes. So the template is set up in a way that it's a lot of things have already been done for us, but they haven't been done correctly. So we are going to go ahead and delete the ARSCN view. We're going to head to the bottom right, type in view, search for a new view instance. There we go, drag and drop. Perfect. Seems to have already filled our area. Just in case, let's add no constraints required. Now we're going to put an ARSCN view, the ARKit scene view. We're going to constrain it to all four corners. Perfect. And we need one more thing, label. This label is going to be part of our UI that will alert us as essentially for different states of our app. We'll get into this a little later, but essentially what happens is that plane detection, rather ARKit, does not load immediately. It takes a little bit to warm up, and unfortunately, when the app goes to the background and returns to the foreground, again, it'll take some time for it to start up. As a result, we need to notify the user whenever we have these changes. So we provide the user with, in this case, very simple UI elements, i.e. a label, to notify them when the app status is changed, or moreover, when plane detection is available. So now that we have our label, we're going to put some constraints on it. Actually, let's make some changes first. So I'm going to make you, we are loading. Let's do a size of 15, automatically adjust font, center, because we're nice like that. Head to background and select the very first option. Perfect. Looking better already. And now what we're going to do is, again, we're going to throw some constraints on. So let's do 10, and we're going to do 10 from the left, 10 from, actually make it 15. 15 from the left, 15 from the right, and we're going to have a height of 40. Perfect. Add 4 constraints. That looks pretty sweet already. So let's head back to our view controller. As you can see, all the way to the top, we have an IB outlet reference for a scene view. This was the ARSCN view that we had prior. However, we deleted it, so we have to restore it. So let's head back to the main storyboard. We're going to utilize the assistant editor. So top right, 2 rings. I shouldn't say most of the time. Sometimes assistant editor actually lucks out and gives us the right file. But in the event it doesn't, you can always head up to the top, go to automatic or manual. In this case, automatic works, automatic, and click view controller, since that's the file associated with our view controller in storyboard. So what we're going to do is control, drag to, actually, matter of fact, we might not even need to do this. Rather, head back to our view controller, hit that plus icon, and then drag it over to our ARSCN view. As you can see, we have a fill circle, and as a result, our reference is restored. So now we're going to make a reference for the UI label. So control drag from the UI label and drop on our view controller. So let's give this the name status label. And let's close this. And we're going to go directly on our view controller. So let's see. To get our 3D shapes, what we want to accomplish is to create a random shape from 4 default shapes provided by Apple and ARKit. And this is the box, pyramid, sphere, and I believe one more tube, guys, tube. So in order for us to do this, we are going to create a new file. So file, new, file, so file. And we are going to call that shape factory. Now what this is simply an enum for easily and quickly creating our default shapes. So the idea is that we won't have to constantly type out the explicit syntax for creating a brand new shape over and over again. Rather, this will provide us with a simple, straightforward way of doing it pretty clean and easily each and every time. So we have foundation, which we actually don't need. Don't need foundation. Import ARKit, import UI kit, and let's say enum shape factory. Now we have our cases are going to be simply the names of the shapes that we want. So case, box, sphere, pyramid, and tube. And we're going to have a property, computed property no less. We're going to call it new, and it's going to be of the type SCN geometry. Now here's the really cool part. Switch self box, and we're going to return SCN box 0.2, 0.2, 0.2, and a chamfer radius of 0. So let's do our next cases. Box, can't spell, guys. Pyramid, and let's change that around. SCN, so 0.2, 0.2, 0.2. Gone ahead and copied it. Pyramid here. SCN sir. Radius 0.2. And the last one, tube. Return tube. SCN tube, perfect. And a radius 0.2, 0.2, 0.2. For the sake of simplicity, I've gone ahead and just used 0.2 throughout. So again, like I mentioned with our previous section, for the equivalent of every meter, basically for every one float you have is the equivalent of 1 meter. So again, simply put, one float equals 1 meter. So in other words, we're doing 0.2 meters for just about everything. And again, for the sake of simplicity. So then we're going to make a static property starting with our count uint32. I know it's a very weird type. It's an unsigned integer 32-bit, but there's a reason for it, and I will show you momentarily. Now the thing is, the reason we're returning 4 has to do with unsigned int32. The reason that we're returning 4 is because 4 is the current count of the number of default shapes that we have in here. So I think we're all set with this. And again, the reason I decided to use an enum that I call Shape Factory was that it provides a very simple and clean way of creating our respective cases. In this case, which are all SCN geometry types, respectively SCN box, pyramid, sphere, and tube shapes, and it'll provide us with incredible ease of use. And it's also a very clean implementation. So I will demonstrate how we're going to use this right now. So let's head back to our view controller. So in our view controller, we're going to map our values. Rather, we're going to map integer values to our enum type. So let me demonstrate. Let value, so we're going to create a dictionary. Let value for shape equals type shape factory equals 0 to autocomplete. You can do it. Perfect. Again, what we're doing is simply mapping our shape enum types to unsigned integer 32, and to basically give you, let's see, it seems we have an error. We've mapped integers to our shape factory enum type. Now, let's head to setupScene, and we're going to round out our label. So status label dot layer dot corner radius equals 20, and status label dot layer dot master bounds equals true. Okay, and let's call our addShape method, which we will be adding right now. So as you can see, again, we don't have our addShape method, and we will be adding it right now. So the addShape method is very similar to a method we've used before. What this will do is essentially give us a random shape whenever it's called. So let's make you shape method. X float we're going to quickly create an array of shape nodes. So we'll call it shape nodes up here. Shape nodes dot append shape node, and then essentially what the addShape method does is simply create a random shape by using ark_for_random to select a random number. This random number is the index which we use to select our respective shape factory type. From this type, we access the new property, again from our shape factory type, our shape factory enum type, and create a new instance of the shape of the enum that we specify. After we create a new instance of the shape, we assign the shape to a new instance of an SCN node, and afterwards, after we have an SCN node, we assign to it its geometry and position. And the position itself is simply an SCN vector 3 from the passed in arguments, which represent its x, y, and z coordinates in the real world. For the sake of convenience, I've also provided default parameter arguments, so I don't have to specify it readily whenever I call addShape. So let's go ahead, test our app, and make sure everything's okay. I'm going to head up top. So now I've plugged in iPhone and we're going to run the app. So let's head back up top, my iPhone, and let's hit, if everything works out, we should have a scene with a nice cube, or rather random shape in view. Hit OK. Now we're going to go ahead and test our app. So hit play, and the moment of truth. Here's our UI, and we have a shape, pyramid. So I have a tube. You want to try again? I have a sphere. Perfect. Seems like we're getting a random shape.